Do we have too many small languages or not enough big ones? I'm Ray Myers. Welcome to Craft vs. Cruft, and we're experimenting with a more minimalist theme today because it is 2025. You know what that means? Well, maybe you don't yet. I haven't told you. But to recap, 2024 was the year of formal methods. We had a lot of great stuff coming out of that theme, and thank you to everyone who's been asking me what's going to be the theme of 2025. Obviously, generative AI back from 2023 is still very much in the picture. We're going to be continuing on with formal methods. I think that'll impact the remainder of my career, to be honest. But the official theme for 2025 is the year of domain-specific languages. So that's what we're going to talk about today. Also known as DSLs. Now, there are reasons why I think that they are going to become more relevant now and in the near future. But to really say why I want to talk about them, we have to go back to the beginning of my career. Back in 2007, when I had my first full-time job as a programmer. And that was at Carfax in Columbia, Missouri. So I'm at my first job. We're doing extreme programming, including test-driven development, and we're writing so many tests. And this is mostly a good thing. The tests were mostly helpful, but they were very tedious to write them all. And in particular, the team that I was working on, there was just lots of fiddly data to set up in these tests. And at the same time this was happening, it seemed like there was one team that was just rumored to be so productive. It was their reputation, is that they were doing extremely well. And when you looked at their code was so short. Their code was also very strange. It didn't look the way that we were used to code looking, even though it was also in Java, just like ours was. And I resolved to learn their ways and see if I could solve some of the problems that we were having using some of these techniques this team seemed to have. What they were doing in that situation, a big part of it was something called fluid interfaces. And those are now would be called a kind of internal DSL. I don't hear that term used so much anymore, but the concept very much still exists. So what I did is I took those ideas and I made my own for my team that was optimized for creating this test data that we were always having to do, try to make writing our tests easier. And this was very successful. 10 lines became 1 line, which means 100 lines became 10 lines. You know, this was a drastic quality of life improvement. Writing tests is now much easier for us. Everyone is happy. I think I underestimated at the time, actually, what a big win this was for so early in my career to have done something that caught on that well for my team in the first year of my career. You know, I have years now that aren't as, productive in that capacity as the first year of my career. So what happened there? Why was that so amazing? Well, I discovered DSLs. In this case, an internal DSL. What are they? They are programming languages. Sometimes they're Turing complete, sometimes not, but at least in the sense of languages used in programming, they are that. But they're not normal ones. They are small and special purpose languages. That special purpose is what we call the domain in the D in DSL, right? But sometimes we mean a business domain. Sometimes we mean a problem domain. The scope in which a DSL might operate, it can take many different shapes. So that's one way you could divide up DSLs. Another way is whether they're textual. We're used to, when we speak of DSLs and programming languages and code, usually we're thinking of text, but actually you have visual DSLs as well. So you might have textual or visual DSLs. Another way you can divide them up, independent again from these other dimensions, is their internal versus external DSL. So I mentioned internal before. What that meant is we didn't have to leave the programming language that we were in order to use it. It was a library that was kind of being creative enough to feel like it was its own language. And an external, of course, means is separate. It's got its own syntax, its own parser, and so on. So just to give some examples, this would be, what you might see in a language like Ruby, a DSL that's for making dates, where you get to write things that are like sentences, one.day.before, passing yesterday, stuff of that nature, So this uses techniques like method chaining, and this is very similar to what was once called fluent interfaces, right? And there's another that is external here, which should also be very familiar to you, which is regular expressions, right? So you're stepping out of the main syntax of a programming language. You're doing something radically different when you use regular expressions, and it's very optimized. Some people don't like regexes. I get it. It is very strained syntax, but in the space of parsing a regular language, which is a technical term, if that's what you want to do, they can be profoundly efficient for that. For instance, this short sequence of characters would be able to match any, positive or negative number that had a decimal component or not, right? And you'd be hard pressed to write some code that could do that as well, that would fit this well on a slide. So another example of an external DSL you use very often is SQL. So when we talked earlier about textual and visual, there's also this middle ground, which are things that are like spreadsheets. So you may not have thought that you're using a domain-specific language when you use a spreadsheet, but I think it's fair to say that you are. And there are a lot of DSL systems that are kind of table and spreadsheet oriented. You can't really downplay the significance of spreadsheets as a programming system, whatever you may think about them, because they are, some of the most successful software products that have ever existed, including, being like, for instance, VisiCalc, the first program, it is claimed, the first program that people bought the entire machine just to buy one application and run it on it. So there's so much variety in the space of DSLs. Why is there this pursuit in the first place that takes so many shapes? Well, think about notation. Let's think about what mathematicians do. We think about a mathematical notation. You might be visualizing an equation and things like, oh, that's math. But there's not just one math, is there, right? There is logic and calculus and arithmetic and complex numbers and lots of different spaces with their own rules. And for different kinds of jobs in math, they create different notations. Sometimes just for one paper, you make up a new notation just for what we want to do here. And that's because when you want to have very effective, consistent thoughts in a particular direction, you often want to shape the way you communicate to purpose. Let's say this in a more poetic way. DSLs are like little worlds. It's an invitation. Come into my little world. This is the concepts that we want to make very easy to express. These are the relationships between them. And this language is going to make certain things very easy to say. Other things are going to become more cumbersome to say, or even be impossible to say. And hopefully that's done deliberately. That might have a lot of advantages. Certain thoughts should be inexpressible within this domain. And this is just the flexibility that kind of paradoxically comes from having these constraints. That's something that's just not very achievable when you're starting out in a general purpose language. So what do you get out of these little worlds? You get efficiency. Often you're able to very quickly, like I gave the example where we're able to, in a few lines, create test data that would have taken us a lot longer before. You also might get quality. You've defined, if you've modeled the domain well, You have defined what rules make sense. You've made the right things easy. You've made mistakes hard, hopefully. You also get accessibility, right? This democratizes is a word you might use, programming, or at least the kind of agency over the business logic, such that the people who are experts in your business domain have more insight and more control over the situation, right? Maybe they're viewing the code directly when they wouldn't have been able to. Maybe they're collaborating with you on it, or maybe they're actually maintaining the rules themselves, and the developers are primarily focused on just the infrastructure. There's a lot of ways that can take, but generally you're giving more power to the experts, and that can be a very good thing. You're empowering the experts. Another thing that you're doing, and you'll see people claim this, though it is a lot of, I think, preconditions for this to work well, is that you're decoupling business rules from legacy code. Right, you picture all these mainframes, these payroll systems that are in COBOL, and it'd be very difficult to get them out because no one fully understands all the behavior this is supposed to have. Well, if we had been using a DSL system, right, then you have in this independently parsable format all of the secret sauce, all of the ways we know the system's supposed to behave, and you should be able to just plug in another code generator and move it to Java or Rust or whatever it needs to be in tomorrow. Now, I will tell you that has happened. This is a real thing. This is not a fairy tale, but also it is quite a challenge to pull that off. Why might you not want to use DSLs? I'm painting a picture of a lot of great things. Well, there is risk management that is being done here, where you're saying, I want to de-risk part of my development, namely the creation of many, many, many business rules. We want to accelerate that and de-risk it. But I am moving that risk onto the DSL engine itself. Is my language technology and my code generation and whatever else might be involved, that now has a lot of risk associated with it, so I better be good at that. And that is challenging. That is advanced code. We're betting a lot on some very advanced code. I think a lot has been discovered about how to do that successfully, but nonetheless, this is non-trivial. You shouldn't walk into that thinking that the investment's going to be easy. Oftentimes, along with that, this DSL technology will have poor tool support. If we're using our standard programming language, we might have an IDE, an integrated development environment, such as IntelliJ or what have you, that is giving us all these capabilities. And then we've moved over into our land of the DSL, and the language looks more appropriate for us, but the tool support isn't there. It doesn't underline when stuff's broken and we can't navigate or whatever else we might want to do. There are ways of addressing that, right? You should consider having tool support if you're going to put in the effort to make a DSL. You should do it right. So with poorly designed languages or insufficient tooling and so forth, we have been burned sometimes by DSLs. Not every time that I've used it was as successful as that initial experiment I told you about. So that's why. And why not? Why now? Why is 2025 of all years the year of DSLs? Well, I believe that the cost-benefit analysis that goes into deciding whether to use that, is shifting. A number of things are making it shift to where it could cost less to do it, you might risk less to do it, and you might get more benefit from doing it. So one of those, we got to have the AI slide, or in particular, large language models, LLMs, right? Language is also the L in DSL, right? So when you think about this problem we always have with using LLMs of needing to get structured output from them, or having a bunch of structured data that we want to figure out a way to feed in them and so forth, DSLs are a very compelling piece of that architecture in a number of ways. And, we may explore why that is. But for instance, think of guardrails on the output of an LLM. if it is producing something code-like and is constrained to write in a DSL, you have a lot more control of what it can and cannot do than if it is producing arbitrary source code you're running. That's just an example. Another thing that's advancing at an amazing rate is formal methods. So you might have expected to hear me talk about that because that's what I've been talking about for the last year. But I'm not the only one to say that formal methods have a huge tie-in with DSLs. There are many DSLs that are just, formal methods projects by themselves, like Z3. But also Z3 is like a platform upon many other verifiable DSLs are written. And in general, if you're going to maintain, this set of business rules, there are a lot of formal methods like, assurances you might want to have over, what rules are allowed to exist and not, and what might it be for these rules to conflict with each other. Formal methods is a body of knowledge that has and a set of tools that has a place here for sure. Another one is language workbenches. So what is that? Well, I mentioned the tool support is often bad in a DSL. And the biggest attempt to address that is language workbenches. You have tools like MPS from JetBrains. You have Xtext and TextX. Various other things. But what these try to do is say, well, when you make your DSL, you get an editor that is smart. That is how you expect editors to be in this day and age. So we'll probably explore that in a little more later. What else? What else is next for us going into the year of DSLs? And I'm going to mention a lot of topics that are related to this. I want to hear from you about which ones you think we should dive into. But of course, we're going to look at some cool DSLs, right? Should we do an episode on regular expressions? We might. But there's just a whole sea of these that I would love to dive in. Comment your favorites. We're going to talk about domain modeling, right? The degree of benefit we get from a DSL is kind of only as good as our understanding of the domain we're trying to optimize for. We're going to talk about compilers. Obviously, you need compiler technology a lot of times if you're doing this. And generally, I have found compiler tech is super interesting. I've gotten more into it lately. And so I'd like to share some of that. Basically, tree transformations are just such versatile, such interesting things. But also the front end of a compiler, parsing, right? Tools like Antler, about how you can very easily create a parser for your own language. We'll definitely dive into that. Abstract syntax trees, I mentioned, that's part of that internal compiler technology. Type checkers, right? One of the simpler applications of formal methods. And so if you're making your own DSL, you might end up making your own little type checker to go in there. And if you're doing that or other kinds of checks, you might use a constraint solver. You might integrate Z3 into your DSL on the back end, to do assurances or even do some of the code generation. That's also done sometimes. If you want to understand how your DSL behaves, you might define its formal semantics. If you want a super fancy editor that will make it more possible to go between one valid program and another, you might look at something called structural editing. So one of the most famous examples of that is paredit in Emacs. That is a mode for editing Lisp programs while keeping the parens balanced. But structural editing is a very general concept you can use in any language. And related to that is projectional editing, where if you have a language that has two different visualizations, say you are looking at like a mermaid diagram that has code and then a diagram. Well, it becomes a projectional editor if you're not only able to update the code and see the diagram update, but you can also go over here and interact with the diagram and the code will update. Projectional editors are, many people think, the future. They've been the future for a while, but maybe really this time. All right. So What else would you like to see? Let me know your thoughts. Thank you for watching. As Lao Tzu said, with patience, the most tangled cord may be undone. Thank you.